In the history of aviation, one achievement stands out as a testament to human ingenuity and the pursuit of speed. Welcome to Breaking the Sound Barrier, the Era of Supersonic Flight, a documentary that explores the technological marvels and the challenges behind the development of supersonic aircraft.
In October 1947, at Muroc Desert Test Center in California, history is made by this aircraft, the XF-1, and its pilot, Captain Charles E. Yeager. This airplane and this pilot are about to be the first ever to fly faster than the speed of sound in level flight.
In 1947, test pilot Chuck Yeager shattered the sound barrier in the experimental Bell X-1. This marked a pivotal moment, opening the door to the world of supersonic flight. The term supersonic refers to speeds faster than the speed of sound, a feat that was once thought impossible. The idea of a supersonic airliner was proposed as early as the late 1950s. In the early 1960s, both British and French aerospace companies started developing detailed designs for a supersonic transport aircraft. The initial design phase involved conceptualizing the aircraft's shape, size, aerodynamics, and other technical aspects. In 1962, the British and French governments signed an agreement to jointly develop the aircraft, combining the efforts of British Aircraft Corporation, later British Aerospace, and Aerospatiale. The aircraft's name, Concorde, was chosen to reflect the harmony and cooperation between the two countries. The Concorde, a joint project between British and French engineers, embodied the dreams of a supersonic future. With its sleek design and cutting-edge technology, the Concorde showcased the possibility of crossing the Atlantic Ocean in just a few hours. It would cruise at twice the speed of sound with enough range to cross the Atlantic, faster than regular jets. Supersonic flight brought forth a wave of technological innovations. Advanced aerodynamics, heat-resistant materials, and powerful engines were developed to overcome the challenges of flying at incredibly high speeds. For many successes, there are many challenges. A big problem faced by supersonic aircraft are sonic booms. A sonic boom is a shock wave or a continuous, powerful sound that is produced when an object travels through the air at a speed greater than the speed of sound. This phenomenon occurs because when an object moves through the air, it generates pressure waves in front of and behind it. When the object surpasses the speed of sound, these pressure waves combine and form a shock wave. This shock wave creates a loud sound, which creates noise pollution. After many protests and violations, commercial supersonic aircraft were banned. The future of travel ended here. Today, a new era of supersonic flight is on the horizon. Companies like Boom Supersonic and Ariane are developing aircraft that aim to combine speed, efficiency, and sustainability. With advancements in materials, quieter engines, and improved designs, these aircraft are poised to revolutionize air travel once again. We would like to introduce our own supersonic plane model. We call it ACE Starliner. It will revolutionize air travel by reducing the time for travel. It will be counteracting all the problems such as pollution and the sonic boom. It will use less fuel and give high range.
Our concept is called as a Starliner. It will revolutionize the future of traveling by avoiding all the mishaps in the past.
The supersonic commercial aircraft in this concept operates at speeds exceeding Mach 2.5. This incredible speed allows passengers to traverse continents in record time. Depending on its design, the aircraft can accommodate between 100 and 125 passengers, providing a balance between speed and capacity. The aircraft features a streamlined body with delta wings optimized for high speed, stability, and minimum drag. This design reduces air resistance and enhances fuel efficiency, ensuring a smooth and efficient supersonic flight.
Embarking on the quest for efficient and high-speed air travel, our aircraft employs a dynamic propulsion system, seamlessly blending the power of two afterburning F101 turbofan engines and two cutting-edge scramjets. During takeoff and landing, the F101 engines provide the necessary thrust, ensuring a controlled ascent and descent. Once airborne, we transition into the turbofans, harnessing their fuel-efficient capabilities for optimal cruising. As we reach the supersonic realm, the scramjets are turned on, catapulting the aircraft to supersonic speeds. Ingeniously, when the desired velocity is achieved, we gracefully deactivate the scramjets, relying solely on the turbofans to maintain the momentum. In addition to the propulsion system, the aircraft utilizes compression lift. Compression lift is a phenomenon where the aerodynamic forces generated during supersonic flight contribute to increased lift, enhancing the aircraft's performance. So during specific phases of the flight, optimizing aerodynamics and further enhancing overall performance.
The aircraft is meticulously constructed, primarily utilizing advanced carbon composites and titanium alloys. These materials provide an exceptional strength-to-weight ratio, allowing the aircraft to withstand the stress of supersonic flight while maintaining a lightweight profile. The incorporation of air vents for feeding air into the engines ensures optimal performance, while the retractable wings in the front along with variable geometry wings contribute to the aircraft's adaptability in different flight conditions. Additionally, the aircraft features two fuselage tanks, two wing tanks and two canard tanks strategically positioned to enhance fuel efficiency and distribution. The use of titanium in the construction not only bolsters the aircraft's strength but also significantly enhances its heat resistance, which is a critical attribute for maintaining the structural integrity during high-speed travel.
The cabin is designed with passenger comfort as a top priority. It offers spacious seating arrangement, luxurious amenities, and state-of-the-art noise reduction technologies. Passengers can enjoy a scenery journey while cruising at Mach 3 or above.
As the environmental concerns, the supersonic aircraft incorporates advanced emission control systems and noise reduction technologies. These innovations are vital for minimizing air pollution and noise pollution associated with supersonic flight.